Right, we're going to be going through questions 14, 15 and 16 from exercise 2c. So I'll start off with question 14. Now the situation is you've got a tower block's 46 metres high. A is thrown down off the top with speeds 5 metres per second, and B is thrown vertically upwards with a speed of 18 metres per second, and at some point they will meet and we have to find the distance from A. We need to find that distance. Okay, as I mentioned to you before, it's quite handy in a lot of questions to write an expression for the displacement of an object at a given time. So if we're going to write the displacement of A, and we're going to take these as separate journeys. So the displacement of A is equal to ut, which is 5t plus a half at squared. Now because it's going with the acceleration, they are the same sign, so I'm going to plus 4.9t squared. An expression for the displacement of B, ut, so 18t. Now because acceleration is going against the direction of s, then it's minus 4.9t squared. Now this is the interesting bit. Where they meet, the distance travelled from B and the distance travelled from A will equal 46. The entire tower block is 46. So the distance that B travels and hits A and the distance that A travels and hits B, those two distances added together will equal 46. And that's the final bit of information we need to know. So if I add these two together and equal it to 46, I'll get an equation, and you'll also notice that the 4.9t squared will handily disappear. Anyway, when we add them together, we simply end up with 23t is equal to 46, which gives a nice answer that they collide after 2 seconds. Now we don't need to know after how many seconds they collide. We need to know the distance from A. So we plug that 2 seconds back into SA. So that'll be 10 plus 4.9 times 2 squared, and that gives me 29.6 metres. Okay, question 15. So we've got situation, we've got a ball falling from rest. It bounces again. We are asked to find this height in part A and this height in part B. Every time it hits the ground, it rebounds with 3/4 the speed with which it hit the ground. Now it starts from rest, so u is equal to 0. It's going down, so acceleration is in the same direction, so we can call it positive. And we know that s dropped from a height of 10 metres. So we need to find the final velocity when it first hits the ground. So we need to find v. Look at what we've got. We're going to plug it into v squared equals u squared plus 2as. So we've got v squared is equal to 0 squared plus 2as. You end up with v being 14. So that's the speed at which it hits the ground. So then the speed with which it bounces back up is equal to 10.5. And that is my new u. So we're trying to find now, the question asks us for the greatest height. Well, we know the greatest height occurs when v is equal to 0. we've got u is equal to 10.5. Now this time the acceleration is equal to minus 9.8. It's going the opposite direction. We are trying to find s. It's exactly the same formula. So we've got no squared, nothing squared is equal to 10.5 squared minus 19.6s. Solve that and we get 5.6 meters. Now, this is the clever, handy bit. Look at the shape of this second stage. So it rebounds, goes up to its greatest height, and goes back down again. If it starts with an initial velocity of 10.5, because this is symmetrical, it will end with a final velocity of 10.5. You can try it, set s is equal to 0, and you know u, find v. It will come out as 10.5. So we know that hits the ground there at 10.5 as well. I'll get rid of a few things. So we know now our starting velocity is another 3/4 of that, which is 7.875. That's our now u. Plug it back into the same formula as we did there, except with that u instead of 10.5. So we've got 0 squared is equal to 7.875 squared minus 19.6s. And this time we get s as 3.2. And there we go, part A, part B. Right, question 16. Okay, so particle P is projected vertically upwards from point O with speed 12 meters per second. 1 second after P has been projected from O, another particle Q is projected vertically upwards. Find the time between the instant that P is projected from O and the instant when P and Q collide. So we're wanting when they collide. As soon as they ask for something colliding, that sort of sparks off that we need to write S, we need to write an expression for S. So, write my little subtext. I've got u, the starting velocity for P is 12, starting velocity when u is 20. Because they're both going upwards, A is minus 9.8. Write an expression for the distance of u. Now P is the one that is set off initially. So that's just ut minus half AT squared. Now this is the bit that will catch people out. So Q is sent up another second later. The temptation is to say, well, that's t plus 1. But think about it. After 2 seconds, after P has been travelling for 2 seconds, how long would Q have been travelling? Well, it sets off 1 second later, so Q will have been travelling for 1 second. So in fact, it's actually t minus 1, not t plus 1. Q is 1 second behind. And I'm sure a lot of people might have thought it was t plus 1. Get rid of this. So those are our two expressions. Now, we can expand this out. We want to know when they collide. Let me just get rid of the unsimplified versions. We want to know when these two collide. So when they're equal to each other. So we've got Let's do a bit of tidying up. 12t plus 9.8t is 21.8t. And we've got minus 4.9t squared. Minus 12 minus 4.9 is minus 16.9. The minus 4.9t's cancel out. We can take away 12t, and I'm going to add that 16.9. Again, carry on up here. So that will give me 16.9 is equal to 9.8t. Divide them and we get 1.4 seconds. Now as I'm stood here, I just realised I've done this completely, you're not completely wrong, I was placing 12 as U for Q instead of 20. Rather than start again, I'll just start from start. So my apologies. I wonder why it's not working. So 12t minus 4.9t squared for P, and that's a Q, is 20. My apologies if people spotted that at the start and thought, what the hell is he doing? If you did, good spot. Okay, let's expand that out. Let's simplify that. Okay, let's make them equal to each other now, as we did before, this time with the proper values. So we've got 12t minus 4.9t squared is equal to 29.8t minus 4.9t squared minus 24.9. So same as before, they cancel out. I'm going to add the 24.9 over. I'm going to take away 12t. That will leave me with 17.8t, and that will now give you 1.4 seconds. Right, part B asks, so that's the hardest bit, the distance to the point where P and Q collide from O. Now we know T, so all you need to do, shove that back into there, and that will tell you the distance from the origin. So shove 1.4 into here, and that gives you 7.2 meters. And that's 14, 15, 16 done.